we will continue 7.5.7. Okay, and the areas of plane regions. And in the subsection, okay, I want to give you the definite integrals to represent the plane areas, and of course I'll give you the definite integral, which is integral from a to the b f of x del x. It measures the area between the graph of the f and the x-axis from x equals to a to the x equals to b. Okay, and but sometimes it treats as negative any part of this area that lies below the x-axis, and of course we assume that the a is less than b, and in order to express the total area bounded by the y equals to f of x, y equals to 0, x equals to a, and x equals to b, counting all of the area positively, and we should integrate the absolute value of f. Okay, and then let me sketch what I mean. Okay, for example, if our blue curve, which is the function curve, okay, starts from this point and end at that point, okay, as you see, and oops, I'm sorry, let me correct this point, and okay, and the symmetric to the x-axis, okay, we can obtain these green dot lines or curve, okay, and this is a1. Okay, and this point is, let me C point, okay, and this is A point, this is B point, okay, and this point is A2, and this point is this area is A3, okay, and the integral from A to the B, okay, and the f of x del x, it equals to a1 minus a2, because of the a2 is negative valued, okay, so you must multiply it by the -1, or similarly, okay, you can write integral from a to the b, okay, absolute f of x, okay, del x, it equals to a1 plus a3, okay, or of course a2, but that means a2 equals to minus a3, okay, and here must be a3, and oops, by the way, there is no rule for integration from a to the b, okay, absolute f of x del x, okay, and as you see, when your integral's value is negative, okay, at it starts from this c point, okay, you can say, I'm sorry, integral from a to the b, okay, and the f of x del x, it equals to integral from a to the c, okay, and f of x del x, okay, and after that minus integral from c to the b, okay, f of x del x. This negative sign comes from here because of the A2 region is negative, okay, you can say that. And let me give you an example to understand it clearly. By the way, evaluate the area bounded by y equals cosine x, y equals 0, x equals 0, and x equals 3 pi over 2. Okay. We know that the cosine x, I'm sorry, like that, and this point is 3 pi over 2, and this point is pi over 2, okay, and this is 1, okay, we know that this is minus 1, okay, and this curve is y equals to cosine, and we are looking for this shaded region, okay, and that means a equals to integral from 0 to the 3 pi over 2, okay, absolute cosine x del x, okay, and the other saying a equals to, okay, integral from 0 to the pi over 2, okay, because of the after the pi over 2 our integral our curve is negative, okay, as you see it is under the x-axis, so cosine x del x plus integral from pi over 2 to the 3 pi over 2, okay, and it's the minus cosine x del x, and after that integration of cosine is sine x, we know that, and the evolution bar from 0 to the pi over 2, and the plus it's the minus sine x evolution bar from pi over 2 to the 3 pi over 2, and as you see this part will be sine pi over 2 equals to 1, and the sine 0 is 0, so 1 minus 0, okay, and I'm sorry, and this part will be minus, okay, and after that we know that sine 3 pi over 2 is minus 1, okay, and the minus sine p over 2 is plus 1, so it equals to 1 plus 2, so 3, okay, square units. Okay, and the areas between two curves and now suppose that our region, okay, which is under the blue curve and which is upper or the above the green curve, okay, and this is our region, okay, and the x, y, and this blue curve is y equals to g of x, and the green one is y equals to f of x. And then suppose that the plane region R is bounded by the graphs of two continuous functions, as you see, g of x and the f of x, and the vertical straight lines x equals to a and the x equals to b, and as shown in that figure, and they assume that, as you see, a is less than b and the f of x is less than or equal to g of x on this closed interval. As you see, always green one is under the blue one, that means, and so the graph of the f lies below that g of x function, and the area A of our region, okay, can be calculated, okay, by this formula, and let me write it. Area, okay, our region's area equals to integral from A to the B, okay, and the g of x del x minus integral from a to the b, okay, f of x del x, and so a equals to, okay, integral from a to the b, okay, and the g of x minus f of x del x, okay, and it is easy to understand, okay, which is upper, so you must write it first, and the other was is the subtracted value, which is the under the first curve, okay, and by another idea to understand this part, okay, let me write the and the green one is like that, and what will we do? Let's take this piece from this interval, and we will call this by the del x, okay, and as you see, here is x, okay, and here we can absolute f of x minus g of x, okay, and this curve was g of x again, and this was f of x, okay. So you can write it by the region of area, okay, equals to integral, okay, from a to the b, okay, absolute f of x minus g of x del x, okay, and let me give you an example. Find the area of the bounded plane region are lying between the curves y equals to x square minus 2x and y equals to 4 minus x square. Okay. And the x square minus 2x equals to 4 minus x square. Okay. So we will calculate the firstly, okay, intersections of these two curves, okay, intersection points, okay, and the 2x square minus 2x minus 4 equals to 0, and the x equals to 2 and x equals to minus 1. These are the intersections, okay, at the x-axis. Okay, and what can we say about that? We know that let me sketch on the coordinate system, okay, and this is x square minus 2x, okay, and the blue one, which is this, that is the 4 minus x square, okay, and this is 4, this is the minus 1, and this point is the plus 2, okay, and now we are looking for this R regions area, okay, and what can we say about these two functions? We can say the blue one, which is the 4 minus x square, is larger than or equal to the green one, which is the x square minus 2x function, okay, it is larger than or equal to for that interval, okay, and when you calculate the total area, you must write the integral from minus 1 to the plus 2, which is the intersection points of these two curves, and the big one, which is the 4 minus x square, okay, minus the small one, x square minus 2x, okay, now x, and after that integral from minus 1 to the plus 2, okay, and the 4 minus 2x squared plus 2x, okay, now x, and after that integrate this polynomial function. It will be easy for you, and the 4x minus 2 over 3x cubed plus, okay, x squared, evolution bar from minus 1 to the plus 2, okay, and the 4 times 2, okay, and the minus 2 over 3 times 8 plus 4 minus, okay, and the minus 4, okay, and the plus 2 over 3 and the plus 1, and it equals to 9 unit square, okay, total area. Example again. And find the total area which is lying between curves. Sin x and y equals cosine x, x equals to 0 to x equals to 2 pi. Okay. And the I want to sketch sine and cosine directly and clearly, so I take this asymptote value, which is the +1 and the -1, not asymptote but this is the, and the continue with the cosine curve, and the cosine curve will start here. Okay, and we know that this value is pi over 2, this is 3 pi over 2, and this is 5 pi over 2. Okay, and the green one, which is the sine function, okay, and the and this is the sine x, and the blue one was the y equals to cosine x. Okay, and the our total area, okay, and the which is this point is, I think, the whatever, and the this point is, okay, and the pi, and at this point is, okay, 2 pi. Okay, and now we are trying to find this total R region's area, and look at the area. Okay, area equals to, okay, integral, okay, from 0 to the 2 pi, okay, absolute value of, okay, it's not important, cosine x minus sin x del x, okay, and when you extract this absolute value, you will obtain, okay, which is upper and which is the lower values, okay, and it will be integral, as you see, this point is pi over 4, okay, and at this point is 5 pi over 4, okay, and it's easy now, integral from 0 to the pi over 4, okay, and which is the upper function, we know that the cosine function, and the cosine x minus sin x, okay, del x, plus integral from pi over 4 to the 5 pi over 4, which is the upper function, I mean that which is under the other function, okay, and the other function is, of course, now sin x, okay, because of the green one is higher or larger than the blue one, so sin x minus cosine x del x, And the last part of the integration, integral from 5 pi over 4 to the 2 pi, okay, and now the blue one is larger than the green one, so blue one was cosine x minus sine x del x, okay. And the calculation, this area and the sine x plus cosine x, okay, and integral from 0 to the pi over 4, and the minus cosine x plus sine x from pi over 4 to the 5 pi over 4, and after that plus sine x plus cosine x, okay, integral from 5 pi over 4 to do 2 pi, and the square root of 2 minus 1 plus square root of 2 plus square root of 2, and the plus 1 plus square root of 2. This part will be cancelled, and the 4 times square root of 2 square units. That is the total result, okay. Okay, and another example. Sketch and find the area of the plane region bounded by the x equals to y square minus pi square, and the x equals to sine y curves. Firstly, we will try to sketch, and after that we will try find the area and the okay, and the blue one, which is the y square minus pi square, okay, and it will be like that. I'm sorry, it's not clear now. This is better. X equals to y square minus pi square. At that point is the minus pi square x and the y axis, and after that x equals to sine pi, I'm sorry, x equals to sine y, that will be okay, and this point is the pi, and of course this point is minus pi, and the x equals to sine y function. Now we are trying to find this yellow region area, as you see. Okay, and now you can rotate this graph, okay, and the clockwise, okay, and the not clockwise, okay, and the clockwise, okay, 90 degrees, and you will see the green curve is larger than the blue curve. So you can write area of region R, okay, minus pi to the plus pi, as you see, okay, and which is larger. We know that sine y, green one, okay, and the sine y minus, okay, and the other one is y squared minus pi squared, okay, and the del y, it is the minus cosine y, okay, and the plus pi square y, and the minus y cube over 3, okay, and evolution bar from minus pi to the plus pi, and when you calculate it, you will find the 4 pi cube over 3 unit square. Okay, and